Recording in progress. This meeting is being recorded.
Can you please mute your microphones? So we'll continue with the design of compound gear trains. We have introduced last time how we design compound gear trains. Now we'll see a new option of gear trains, which is reverted gear trains. The main difference is that in reverted gear trains, we place the input and output gears on the same shaft. While if you look at your compound gear trains, you have the input shaft will only contain the input gear, and the output shaft will just contain the output gear, and the intermediate, if you want, sats will be constituted of gears on parallel gears on same shaft. Okay, now when we want to put the input and the output on the same shaft, this is called reverted gear train. And to achieve a reverted gear train, we have some additional constraints to add in the design. We'll see why. Because here's a figure of a reverted gear train. So as you can see here, you have 4 gears. 2 of them are on the input shaft, and 2 others are on the second shaft called counter shaft. Why we call it counter shaft? Because it will allow to reverse the direction of the angular velocity. And here, because we'll reverse 2 times, the angular velocity of the input and the angular velocity of the output will have same directions. Okay, so if we look at the process here, first, let's say N2 is our input gear. Okay, we impose on 2, let's say, an angular velocity in the counterclockwise direction. 2 is in mesh with 3. So 3 will rotate opposite to 2 because 2 and 3 are in mesh with an external set. So 3 will rotate clockwise. And because the 3 and 4 are mounted on the same shaft, then omega 3 is equal to omega 4. So we can say that omega 3 is equal to omega 4. Okay. And then what will happen is that 4 and 5 are in mesh. Okay, so 4 and 5 will rotate in the opposite direction. So now 5 will rotate also like gear 2. 5 will rotate into the counterclockwise direction. Now just please pay attention. It's true that the input and output shaft are concentric, but they are not, if you want, they do not form one part. There is a big difference. Yani, the axis of the input and output shaft are collinear, so they belong to the same line, if you want, but they are different shafts. Yani, we can say that they are they share same direction of axis. So the 2 axes of input and output shafts are collinear, but they are why they should be not welded together, because if they are welded together, you are forcing then 5 and 2 to rotate at the same angular velocity. So there is a difference, if you want, between this part here, these 2 and these 2 here. Okay, 3 and 4 belongs to the same shaft. So as you can see the presentation here, this is one shaft and both are welded to it. So this is why omega 3 equals omega 4. Now when we compare 2 and 5, for 2 and 5 they have concentric shafts sharing same axis direction. Okay, but the 2 axes of course are not welded together. So you can see here the shaft of the input from this side and the shaft of the output from the other side. Okay, now In this configuration, we have some additional constraint in the design. Why? Because as you can see, 2 and 3 are in mesh. Okay, so this means that if I want to consider the distance between shafts here, this total distance can be decomposed into the pitch radius of 2. So this is R2 plus the pitch radius of 3. Okay, so the total distance between centers can be written as R2 plus R3 will give me the distance, the center distance. But at the same time, because we said that the input and output shaft are concentric shafts, so they are along the same line. Okay, then also gears 4 and 5, which share the same centers, if you want same centers, if we do the projection. Okay, of course, if you take the profile view, this is the center of 5, this is the center of 4, this is the center of 2 and 3. These centers are in different planes. Okay, but when you do the projection here and you look at this view, so for this view here, okay, both centers are, if you want, coincident because their projection is the same. So when you project these two centers and these two, you realize that you get the same point here on the figure. And this is why you can see also this on the figure here. You can see that the distance between the centers is equal to the distance between the shafts. So this distance here is equal to this distance here, equal to this one. And if we look at 2 and 3, this distance is the summation of pitch radii of 2 and 3. And if you look at 4 and 5, this distance can be also written as the summation of pitch radii of 4 and 5. So I can decompose it in another way. I can say that it's equal to R5 plus R4. Okay, so now whenever I have a reverted gear train system, I should add to when I write the design equations, one of the design equations is that R2 plus R3 should be equal to R4 plus R5. And of course, since the diameter is 2 times the radius, so this formula will hold between pitch diameters. So D2 plus D3 equals to D4 plus D5. Now, all gears constituting this gear train will be characterized by the same diametral pitch. Okay, and we already defined the diametral pitch as N over D. So already, of course, you know that for two gears in mesh, they should have same diametral pitch. And here, because we are using all gears in same assembly, so we will also use same diametral pitch for all. So you can say that diametral pitch of 2 is equal to diametral pitch of 3 is equal to diametral pitch of 4 and 5. This means that you have N2 over D2 is equal to N3 over D3 equal to N4 over D4 equals to N5 over D5. And now you have a mathematical rule stating that if I have N2 over D2 equals N3 over D3, if I add the numerators and the denominators, I get that this should be equal to N2 plus N3 over D2 plus D3. And the same will apply here. So here, this will give me, so this should also equal to N4 plus N5 over D4 plus D5. And since I already have that D2 plus D3 is equal to D4 plus D5, then I also can write a constraint equation for the number of T's, and 2 plus N3 should be equal to N4 plus N5. So I can use this relation in the design process of a reverted gear trains. Now we'll take several examples together to see how we apply these relations in order to come up with the sizes that we should use. Okay. Now, whenever you have to do a design, depending on the ratios I give you, for example, if they tell you design a system of ratio 1/20, this is equivalent to designing also a system to give you a ratio of 20/1, because the only thing that will change is who you put as input and who you put as output. Okay, you know that if you have to design a system in a way that your gear ratio is 1/20, this means that the omega out omega over omega in should be equal to 1/20. Okay, so you are reducing the angular velocity, so the output angular velocity should be reduced. If you want to reduce the output angular velocity, what do? You put the pinion as input and the gear as output, because you know that the pinion angular velocity is larger than the gear velocity. Okay, so whenever you want to decrease the angular velocity, your driver gears should be the inputs. Okay, so here this is your pinions, your main pinion. You have a driver here, and the second driver is N4. Okay, 2 is driving 3 and 4 is driving 5. So if you desire to decrease the angular velocity, then your driven gears should be of bigger size, and the gears in the set will pinion بيكونوا هن الدرايفرز. Okay, so here these are the two driven gears. Now, if you want, you can use the same setup, okay, to produce an angular gear ratio of 20/1. The only difference ساعتها انه بغير مين الانبوت. if you say instead of putting my pinion as input, if I put my gear as input, هلا اذا بحول ال5 هو يكون الانبوت وال2 هو الاوتبوت, I can keep the same sizes. Okay, so this is why in the design, when you design a system to give you a ratio of 20/1, it's equivalent to design a system to give you a ratio of 1/20. لأنه بس بتفرق إنه بس بدي أعمل reduction للvelocity, I put my pinions as drivers and my gears as driven gears. And if I want to increase the angular velocity, I have to have larger angular velocity at the output. ساعتها I put my gears 5 و 3 هن بيصيروا الدرايفرز, and 2 and 4 هن بيكونوا الدريفت. Okay, so this is why حتلاحظوا بالproblems انه اوقات بيطلبوا منا 20/1 بيشتغلوا على 1/20, because the final set is the same, just I change if you want مين حيكون الانبوت مين حيكون الاوتبوت. Okay, so let us do together an example. They want us to design a reverted compound gear train with capable of creating a train ratio of 18/1. So To create this reverted train system, compound gear train system, already I can say I need at least 2 sets. Okay. As usual, I start with the minimum possible number of sets. If this is fine for me, okay, I stop here. If not, I can then increase, if you want, the number of sets that I have. So let us say I will start with 2 identical sets. I have that the total ratio is omega out over omega in, which will be the product of each set of gears. Okay. To have the total ratio equal 18 with identical set, each set should be characterized by a gear ratio of radical of 18, which is 4.24 something. Okay. Whenever you have a rational number with if you want, then you cannot write it as a fraction, then it's not possible to find an exact solution. So no need to try. Okay. So if you have a fraction, you do some trials, but if you have radical of a number and this cannot be transformed to a fraction, then of course you cannot find the number of t's that are integers and that will satisfy this condition. You can do some trials and you will see that you will not get an integer. So if you try, for example, as we said last time, in general they give you the pressure angle. If they don't mention what is the pressure angle, use a pressure angle of 20 degrees. Okay, because this is the most common angle used, unless they told you, for example, that the application is characterized by low power transmission, so you can go up to 25 degrees. Okay, so here I can do some trials, 14, 15, 16, 17, whatever is N2. With this ratio, I will always get N3 with a decimal number, so I cannot get an exact solution. So the best thing to do then is to decompose 18, okay, into multiples. Okay, so I say that 18 is multiple of what, of which numbers. I start to say I divide first 18 by 2, I get 9. I divide by 3, I get 3. I divide by 3, I get 1. So 18 can be written as 2 times 3 times 3. Now, since I want to select 2 sets, I have different possible combinations. I can, if I combine these 2 together, they will give me 9. So the first possibility is 2 times 9. And also I can combine 2 with 3, then I get 6 and 3. Of course, this is better. Always select the one with numbers that are close to each other. So 3 and 6 are closer to each other than 9 and 2. And then this is the best match in my case. So first, I will say that to design a system with a gear ratio of 18 or 1 over 18, which is equivalent as a final result, just the difference is who is the input, who is the output. I have to take the following 2 ratios. I have, for my first set, I have the ratio and 2 over n3 should be equal to 1 over 6. And for the ratio and 4 over n5, it's 1 over 3. اوكي هلا كان فينا ما نقلبها ل 1 over 18. هلا هن عادة they do the design based انه البinion هو الانبوت والgear هو الاوتبut, but you can reverse it. يعني if you want you can directly here say I will work with 18 not with 1 over 18. It's the same. You will get at the end same numbers. Okay, so here you can say that n2 over n3 should be 6 and n4 over n6 should be 3. Okay, now this is a first relation between the number of t's. So n2 over n3 is 1 over 6 and n4 over n5 equals 1 over 3. Since we are dealing with a reverted gear train, we should keep in mind also that a second condition is imposed by the distance between centers of shafts. So I have that because of the reverted gear constraint, I have the following condition. I have that n2 plus n3 should be equal to n4 plus n5 should be equal to a certain integer number k. Okay, now let me try to see how to use this result. What I will do, I will combine this equation with the previous one. From the previous relation, I know that n2 over n3 should be equal to 1 over 6. Okay, and this will give me n3 function of n2. Okay, so I can say that from this result, n3 is 6 times n2. And the other ratio will give me that n4 over n5 is equal to 1 over 3. And this implies that n5 is equal to 3 and 4. Now, once I related n3 to n2 and n5 to n4, I can go back and replace in the constraint equation. So let me replace n3 by 6 and 2 in this relation. I got 6 and 2 plus n2. So n2 plus 6 and 2 equals to k. So 7 and 2 equals to k. This is the result of first replacement. Now, if I use the second result, n5 equals 3 and 4, I replace n5 here by 3 and 4. I get n4 plus 3 and 4 equals to 4 and 4. So 4 and 4 equals to k. What is the conclusion I can make from this result here? I can make the following conclusion. The integer k is a multiple of 7 and also is a multiple of 4. Okay, so the minimum possible value of k is what? The minimum possible value of k is 7 times 4 times 1. This is the first possibility for k. Now, will we try it? If it's a good combination, if it gives us a number of t's for the opinion that is acceptable, okay. If not, we move to the second possibility. The second possibility for k is 7 times 4 times 2. Also, we check it. Not fine. Okay, we pass to 7 times 4 times 3. We continue to increase k until reaching an acceptable combination. Okay, so, and we'll see, you know already how to check for acceptable combination. In general, we try to avoid interference between gears. Okay, so let us try first. Let us start with the smallest possible value of k. So as we said, k should be a multiple of 28. The minimum possibility of it is k equals to 28. Now we already developed a relation between k and n2 and k and n4. So for the first possibility here, you have k equal to 7 and 2. If I replace k equal to 7 and 2 equals to 28, I get that n2 is equal to 4. And this is a very small number of t's for the opinion, which is not desired in general. Okay, and you can check this from the interference table. If you go back to your interference table, okay, if you are dealing with an angle of 20 degrees, okay, so as I told you, if they don't mention what is the pressure angle in the problem, always use 20, because this is the most common pressure angle used. So here, to avoid interference, I should be above 13. Okay, the minimum number of pinion teeth is 13. So of course, any number of pinion teeth below 13 will lead to interference, which is not desired. So I say no, as this option is not good. Let me try another one. Okay, so now I move to the second possibility. I say, what if now I multiply by 2? Okay, so I use the second possibility. I get here, you can directly, if you want, say if I multiply k by 2, the number of teeth of the pinion will be multiplied by 2, which is 8. Still, not acceptable. Okay, and if I multiply by 3 k, then I get 12 t's, also still not acceptable, below 13. So I can directly move to multiply k by 4. If I multiply k by 4, I get 4 times 4, 16 t's for my pinion, which is larger than 13. This is okay for me. Okay, and now I should check that my gear size will not allow interference. So already I know the relation between N3 and N2. N3 is 6 times N2 equals to 96. I can go to my interference table and check that for a number of t's equal to 16, what is the maximum number of gear t's without interference? It's 101, which is larger than 96. So this is good for me. Okay, so I can say now, since the number of t's here is smaller than 101, then it's fine for me. I can stop here and say for this choice, it's good already for N2 and N3. But I still need to check for 4 and 5. Okay. So now for 4 and 5, to get N4, I have that k is equal to 4 and 4. And since k was established to 112, then this will result into N4 equal 28. And this is a very good choice already, yani, because you know from the table that any pinion of size of number of t's larger than 18 will not lead to interference. So if you go to your table, any number of t's above 18 will lead to no interference. So I am okay with any choice here. This is why I can say that for the following result, for N4 equal 28 and N5 equal 3 and 284, I am fine. Okay. And already if you know, larger is the number of t's of your pinion, larger is the minimum number for of t's for the gear to avoid interference. So since N3 is 96 and N5 is 84, 84 is smaller than 96. يعني حتى without looking at the table, you can be sure no 28 with 84 will not produce any interference, because 28 is larger than 16 and 84 is smaller than 96. وكل ما قربوا السايزز من بعض كل ما خفت يعني كل ما بتروح possibility of interference. Okay, so always as the pinion size increase, the range of sizes for the gear for no interference will also increase. Okay, so whenever you have N4 larger than N2 and N5 smaller than N3, 2 and 3 was acceptable, يعني أكيد 4 and 5 will not lead to interference. Any question until here? Okay, now so we say that these are our possibilities. Okay, now if we want, as we said, if we want to have a gear ratio of 18, we put 5 as input or 2 as output. And if we want to have a gear ratio of 1/18, ساعتها بنحط البنيون هو الانبوت، هو N2 هو الانبوت والN5 هو الاوتبوت. But the combination N2, N3, N4, and 5 will remain the same. This is why when you do the design, you can do it for a ratio of 1/18 or 18. It's similar. Okay, you will get same values for your 4 gears. Just you switch between input and output. If you want, depending on the application, if you want to increase the angular velocity or if you want to reduce it. Okay, now let us do another example. Design a reverted compound gear train with an exact train ratio of 40/1 and a diametral pitch of 8. As I told you before, in a reverted compound gear, we use the same diametral pitch for the different gears. Here they imposed on us the value of diametral pitch. So once we get the number of teeth, we can deduce what is the diameters for the pitch diameters for the different parts. Okay. So let us start with our gear ratio. Our gear ratio is 40/1. As usual, same procedure. We start with the minimum number of possible sets. The minimum number of possible sets is 2. Then we say that mv is ratio of angular velocities, omega out over omega in. It should be here equal to 40. So this is 40. And then for each set, the ratio should be radical of 40. Again, this is not a rational number, so I can be sure that I cannot find an exact solution. So I can directly try to decompose 40. So I say 40 to decompose it. I start by dividing by 2. 40/2 is 20. Over 2 it's 10. Over 2 it's 5. Over 5 it's 1. So this will give me 1. And then I can write 40 as 2 times 2 times 2 times 5. Okay. Now, because I am considering 2 sets, I have several possible combinations of gear ratios. First, I can say I can take 2 with 2 and 2 with 5. This will give me 4 and 10. But I can select a better combination. If I take 5 alone, and 2 times 2 times 2 will give me 8. So of course, gear ratios of 5 and 8 are better than 4 and 10. Okay, so I will select this option because this is the closest possible ratios I can reach. And now I start to write my equations as usual. Okay, so first I decompose into factors 40. Then I determine the possible combinations and select the one with the smallest, if you want, the closest ratios. Okay, now once I do this, I say that I can decompose my equation into the following. The gear ratio, the total gear ratio, is the gear ratio of the first set times the gear ratio of the second one. So it's minus n2 over n3 times minus n4 over n5. I remind you that we are putting here minus because gears are meshed in external sets. Okay, so you get for your first, one of your ratios is 5 or 1/5. As I told you, you can do the design على 40 أو على 1/40. Okay. In general they are used to take the configuration of reduction لأنه إنه بياخدوا البinion as input والgear as output. Just by reversing input and output, you get 40 instead of 1/40. Okay, so they set here n2 over n3 to the first value of gear ratio. You have 1/5, and for the second 1/8. And now you get from this result, you have that n2 over n3 is 1/5, and n4 over n5 is 1/8. Now you move to the second step. The second step is to use the constraint of reverted gear. Okay, for the constraint of reverted gear, you should have n2 plus n3 equals to n4 plus n5 equals to k. So as usual, you start to say, I know already the relation between n3 and n2. So I can replace in the constraint equation, I can replace n3 by 5 and 2. And once I do this, I get that 6 and 2 is equal to k. I will follow the same procedure for the second result, and 5 equals 8 and 4. I can replace and 5 by 8 and 4. So you get the second equation is 9 and 4 is equal to k. And now you say from this result, I have that k should be a multiple of 6 and also should be a multiple of 9. So the minimum possible value of k is 6 times 9. So you can start with k, you can start with 6 times 9 times 1. This is the first possibility. If it works, it's fine. If not, you try the other choices. So the second possibility is 6 times 9 times 2. Then you move to 6 times 9 times 3, etc. Okay, when you reach an acceptable combination, you stop. Because in general, we desire to have the minimum possible dimensions, okay, for our gears. This is why whenever we reach a good combination, we stop. We don't look at larger sizes due to space constraints. Okay, so now we start. The first possible value of k, as we said, is 6 times 9, which is 54. If we set k equal to 54, then n2, okay, will be equal to 9. And we know that 9, if we are working on the value of pressure angle 20 degrees, this is smaller than 13. This is not acceptable for us. Okay, so we say no. Let us try other values. Okay, so we have, so as you can see, we can see this these iterations here. So as we said, we will try different multiples of 54. So to start with, the first combination will give us opinion. Oh, sorry, 1 second. Let us check it here. It's n2. K equal to 6 times n2 equals to 54. Okay, so n2 is equal to 9. بعرف ليش حطوها هن 6. n4 is 6. n4 is 6. Okay, يعني if you solve for n2 and n4, n2 you get it 9, n4 you get it 6. Okay, يعني one of your opinion will have 6t's and the other will have 9, and both are not acceptable already. Okay, so this is why we should move to هلا انتوا always check the smallest number. يعني here's the smallest number will be for n4 here. So what you will do, check always the smallest opinion. So the first possibility will give you n4 equals 6. It's not acceptable. Check now another possibility. If you multiply by 2, you get 12. Still also not acceptable, because I want my opinion to have a number of t's lower than higher than 13. So now if I multiply k by 3, I get n4 equal to 18. And then this is an acceptable number. It's larger than 13. Okay, so here so as you can see here, they just switched the equations. لأنه they are taking the smallest opinion as n2. Okay, so if you check for the values of n2, the acceptable one will be for, as we said, will be for k equals 3.